Good morning, ladies and gentlemen. Thank you very much for joining our online seminar this morning. You are extremely welcome. We have a very high quality panel for you who are going to share some thoughts, particularly on the topic of data. Now, we're told every day, aren't we, about the importance of data and how it's going to transform our lives. And indeed, here at ENSA, we've done some modeling, and it does seem to be the case that data is going to be a core topic for every professional role, not just the data professionals. So we wanted to bring together our Learning from the Living Lab project in a hopefully fairly digestible way to you. And to do that, we've got this online session, which is the last of our online sessions. And then we'll be picking up these themes at our two major conferences, first of which is next week. Let me tell you who the panel is, and then we'll jump in. So I'm Neil Robertson. I'm the Chief Executive of ENSA and the Chair of the Living Lab Programme Delivery Board. And the Living Lab is the TIES Living Lab project is a part government, part industry funded project to advance modern methods of construction. Today's panel, we have 4 academics and, well, 3 academics, 1 expert and 1 top executive. So this is going to be the epitome of thought leadership for you today. And you see that they have those things at the back of the Sunday Times, don't they, about making you more intelligent. Well, I guarantee that today's call will do that. So let me introduce the academics first. We've got Doug Forbes, who is a Director of Whole Life Consultants and an Honorary Research Fellow at the University of Dundee. And Doug is a long-time partner of ENSA and has carried out research in benchmarking, metrics, etc. in construction for more than 15 years. We have Bill Gething, who's Professor of Architecture and Deputy Director of the Centre for Architecture and Built Environmental Research at the University of West England. And last but not least, from the academics, we have Phill, who's Associate Professor and Applied Economist and Econometrician at the Institute for Transport Studies at the University of Leeds. We have Chris Fry, who is our leading green expert. Chris is Managing Director, Accelar, and an entrepreneurial business leader, and a real thought leader in the area of environment. And to keep them honest and ask them hopefully some quite difficult questions, I'm delighted that we've got Marc Rozsa. Marc Rozsa leads the Programme Management Office at the Smart Motorways Programme for National Highways, and I don't think you'll mind me saying it makes always a distinctive and incisive contribution to our discussions. So the format will be we'll hear from each of the speakers for 10 minutes. My job is only to keep them to time. Marc will follow each presentation with a couple of questions. You have the chance to ask questions, of course, as well, and we'll do that. There's a question facility on your screen, so please use that, and then I will field those at the end. I'll be having my camera off as much as possible because it looks like I've been fighting. It's just to reassure you, it is just my hay fever, and I haven't been in any scraps, but nobody wants to see that. So without any further ado, we're going to go first to Doug. Doug, please introduce your thoughts for us today.
Thank you, Neil, for that introduction, and really pleased to be opening this session here today, which you'll hear from myself and my colleagues around what it is we're doing around harnessing data to drive that cultural change in transport infrastructure. I'm presenting today on behalf of my colleagues, whose names are on the screen there, the University of Dundee and Whole Life Consultants, and the work we've been doing in one of the projects on the TIES Living Lab. But really, this work has been done in collaboration, and is a collaboration of all of the analyst consortium, which are subject matter experts and research organisations, and the TIES partners, the arm's length bodies who've been involved with what we've been trying to do. So my role here today is just to introduce what we're doing, to understand the the overarching importance and requirement for data, and to set things up for some of the more practical examples and case studies that my colleagues will run through in the remaining part of this this session. So what are we trying to do, first of all, in the Ties Living Lab? We're trying to get that better understanding of performance, including cost, and in particular, whole life cost and other performance areas, to help create that benchmark and use that data to help inform decision making. And to that end, that benchmarking and that metric setting sits very neatly with publications such as the TIP Roadmap, the Construction Playbook, and other initiatives that are going on at the moment to try and help drive that forward. So I would just like to set the scene a little bit around what it is we're trying to do and how we're trying to get that data out. So firstly, why do we need good data? I think ultimately we need good data so that we can make better decisions, and we've got an evidence base for those decisions that we make. And as Neil said at the start, people are starting to increasingly see the importance and the value of good data to being helped to do those 2 points. However, it remains a rarity that there is a sufficiency of good, high quality data that helps you do that. Now, why is that? There are many reasons why that good data out there might not be available. It's a pain in many ways to collect it. That can be collected for different purposes and different requirements, different standards, different options. But that leads to the 2 things that you'll see there on the slide. A survey carried out by Autodesk last year identified that 45% of respondents felt that less than 50% of project data was actually usable. Now that is concerning. Why is that data being collected? Why is it not usable? And how can we make that data better? Across government, there's a quote on there around the Data Management Association who believe that 10 to 30% of revenue is spent on handling data quality issues. So how can we improve that one? Now that one's not particularly construction specific, but it gives you an indication of the scale of the issue and the challenge that we are facing. So what are we doing in the Living Lab to help to try to address that and to move that forward? We are trying to measure performance over 9 performance areas, and you'll see those on the screen there. We've set up communities of practice, and communities of practice are made up of subject matter experts and research and business experts in these 9 areas to help share ideas and share knowledge about what we should be collecting and how we should be collecting it. And there's a multiple of dimensions to those 9 areas. It's not just around collecting them at capital stage, it's around collecting them throughout the life cycle. And at varying levels, right down from asset to project to program, so we can roll those up and understand what we're looking at. And in all of those 9 areas, we've defined and we've managed to agree sets of metrics, which we think will be the ones that we should collect so that we can get a reasonable measure and handle on what we should be measuring and how we can then measure performance. So what we're trying to achieve with that, where are we trying to go? We're trying to use that data to help inform decision making. So having defined the metrics, how do we then use that and how do we specify that so that we can actually make the decisions based on that data? And one of the ways we can do that is through benchmarking. And we can see here an example of a benchmarking chart on here showing that for a range of 20 or so projects, a benchmark value in there of 8. Let's not worry what that benchmark is, but the questions that then arises is, why are there so many projects that are performing, why 50% of the projects are performing better, some at almost twice the level of performance of that particular project, and why are some so much lower? So there's a need to be able to dive in and understand that. However, without good data, we can't answer some of those questions that I posed. We can't answer some of the questions around why performance might be different, because it may well be, although on the face of it, these projects seem apparently similar, there might well be underlying differences that we can't necessarily extract out and understand what's going on. And then we run the risk of not just comparing apples with oranges, but we don't get down to compare the Granny Smiths with the Granny Smiths. So that's really where we want to get to. And to do that, we need to capture attributes. We need to capture details, both contextual and physical attributes about a project so that we can then understand where those differences are and what's driving that performance so that we can ultimately improve and get towards that, that good end. So how are we achieving it? There are three strands in there that we're trying to achieve. There are the people strand, which is that collaboration component, and that's around the communities of practice that I mentioned a moment ago. 9 communities of practice of arm's length body experts who are coming together to help decide to solve these problems, understanding what data they need to collect and how we can best make that change to get that better data in there. We're looking at processes, we're looking at the protocols, defining what should be captured, how it should be captured, and to capture minimal data to make sure that we create least pain in data capture while still getting maximum benefit from it. And technology in there as well. We've got the central repository. We've got the central repository that we're looking at to try and capture that data and that information, and to record that data in a consistent way, and then share that across arm's length bodies as well. So ultimately, it's about bringing those strands together to get maximum benefit. And just before I nearly conclude on this, I just want to give an example of one of the challenges we've got with data, and use an example of productivity. Now, the preferred metric we have on productivity in the Living Lab is GVA per cost of labour. Now, what we can see in here is that if we measure productivity in different ways, and that's not to say that these examples are measuring in different ways is right or wrong, but if we measure it in different ways, we get different answers. So if we measure, as shown on the left there, GVA per hour worked, we can see construction over time lags behind manufacturing and the whole economy, the red line shown on there in construction. So that's one story coming out of that. But the other story, if we look at GVA per unit cost of labour, actually shows productivity in construction higher than professional services and manufacturing and closer to the whole economy line. So the question is, what are we trying to achieve? What are our strategic objectives and goals that we want to deliver? And how do we get data that actually helps us dive down and understand some of these causes and these changes in difference here? Now, there's a lot more work to be done on this, a lot more that I can go into in 10 minutes, but happy to have that discussion if people are interested. But there are opportunities there to say, how can we get better data to help inform what we're doing and move that decision on. So where do we go from here? And just to conclude, the Living Lab is an enabler of the future. The Living Lab is setting up those processes, the technology and the people to prepare for the future. So we're looking at the protocols, we're looking at capturing those attributes, understanding and defining what we need to capture and how we need to capture it, so that we do compare with like, and so that we can understand, as some of my colleagues will speak in a moment, about what drives performance on a particular project. We've got the central repository, which has been developed by the Office for National Statistics, looking to capture data and record data in a consistent way, with the flexibility to look at the future, to store that data and move that on. And lastly, but by absolutely no means least, we've got the communities of practice that underpin, and these are networks of technical experts looking and actually trying to develop collaborative benchmarks that work across organizations to help improve and create better opportunities for data gathering and data collection and data understanding in those organizations. So just to conclude, how do we do this? We need people. We need people to get value from it, and the more value people get from it, the more we can improve and the more we can make better decisions on the back of that data. So that was what I wanted to cover, and I think, Marc, you were going to pick up now. Thank you.
Marc, I think
yes.
you might be on mute.
Yes, thank you, Doug.
Yeah.
Really.
I can't hear Marc.
Can you hear me?
We've lost Marc for a minute, just at the crucial moment. Let's give Marc are you back, Marc? Whilst Marc's coming back, Doug, just from me, one of the things we find is you mentioned people at the end there. How do you, have people got the? Is there sufficient data? I wouldn't say skills or appreciation of data. Are people ready and open for this, or is part of the job also to educate people about the importance of data as well as the technical facilities you have here?
Yeah, I think there's two strands to that, Neil. Absolutely. I think in terms of there's education in terms of understanding the how to analyze data and how to develop data, but there's also understanding the value of it. And I think that comes back to that. The title of this presentation around cultural change. How are we trying to drive that forward? And I think one of the key things that journeys we've been through in the Living Lab is that incremental change. And I don't think we can necessarily come in with a radical overhaul and start collecting everything under the sun overnight. But if we can start making those small changes and then demonstrating to people the value that they can get from that data, how it helps them in their day job, and people are understanding that, people can see that value, that then helps create this virtuous circle that helps spiral and encourage people to collect data. So it is absolutely a journey, Neil. It's not something we're going to necessarily change overnight, but it is something that we can take people along with us on, and we've seen some fantastic results of that in the last 2 years.
Great, Doug. Thank you.
Can you hear me now?
Yes, thanks, Marc. You're back.
Sorry about that. So yeah, I was saying, Doug, really interesting presentation and so topical in today's sort of digital world. Organisations such as ours, arm's length bodies, have been collecting data for many years to meet sort of their strategic objectives. Do you think that the current methods and systems need to radically change to improve the data capture more effectively?
I think, Marc, kind of tying into the response I gave to Neil a moment ago, I think it's around that incremental change, taking those small steps rather than trying to radically overhaul things overnight. And one of the things we've been doing is working with colleagues in the LBs to understand what they currently collect, and an action and an activity that's going on within the COPs at the moment is understanding where do we go in terms of the next steps, where are the key opportunities which are not drastically different from what's being done at the moment. And one of the key challenges we do have out there is the fact that a lot of data is collected, but quite often there can be key components of that we miss, and actually you lose a lot of the value as a result of that. So how can we make those? How can we improve make better use of what's already there and make that step change? Because ultimately it's about inspiring people to want to do that change.
Sure. And just one of the challenges that we have in sort of our organisation is often we're contracting with what we call tier 1 contractors, and a lot of the richer data and information resides in the deeper supply chain partners of those tier 1 contractors. How would you propose that we obtain data from sort of those deeper sets within the wider supply chain in a consistent manner?
I think there's probably two approaches to that. There's the carrot approach and there's the stick approach. And in terms of the stick approach, obviously there are contractual requirements. We can start to specify that data must be provided up through the supply chain, but that's not necessarily always the best route to go down. And then there's the carrot approach, where you're trying to encourage people to collect data because they can see the value in it, because although that might rest within lower tiers of the supply chain, they will start to get value and opportunity coming out of that if they can start sharing that data. So if we can, a middle road will probably be somewhere between those two approaches. But then drawing on that data, within the supply chain is absolutely crucial. And a few weeks ago, Charlie Davies from Costian presented on the Intelligent Infrastructure Control Centre, and that is an opportunity to try and capture data from the supply chain in an automated way. So it's making people's life as easy as possible. But coming back to the very first slide, one of my early slides, around actually, is the data usable? Because people don't want to give data if it's not going to be used, or it's just going to sit in the shell. So how can they actually see benefit and value from that data? So it involves, to get there, it involves clients and all tiers of supply chain working hand in glove to be able to get that data at the right time.
One last question then, please, Doug, if you don't mind. You mentioned the ONS and the central repository. How is it that users can get access to this sort of data and information so that it's more widely shared and learned from?
Yeah, so the central repository, I mean, I think that's and the protocols, they're being developed, and they're nearly there, available to go live. In terms of access to them, that would be through the communities of practice and engaging with the communities of practice who understand what's going on there, and also the body to which the COPs relate into is the Cost Performance Benchmarking Steering Group. So it will be in that governance structure there, Mark.
Okay, thank you, Doug.
Thank you.
Thanks, Mark. Great questions. Let's hear from Chris now, please.
Great, thanks very much, Neil, and Mark and Doug as well. So if I just bring up my presentation as well, and yeah, really going to move on into talking more specifically about the environmental and carbon data as well. So just trying to bring that one up. I don't think that's come up yet, has it, on the screen? There we go. No, that's not clicked through, so I just need to give that one another go. So I'm presenting here on behalf of a fantastic team at Accelar. We've been working on the Living Lab as one of the partners, and also, as Doug said, just very keen to give due thanks to the community of practice that we've been working with. In fact, 4 communities of practice, the environmental and carbon experts across the various infrastructure client parties. So it's been a really good collaborative effort around all of this. So I'll just give this one more go. If not, perhaps Doug, you could push this back into your screen and we can move through the presentation that way. It's got a bit of a glitch in the system. It's not letting me.
So whilst Chris is doing that, just a thought from me from the PMO side of things. The Living Lab's been a long time in the making, and we were focused very tightly on whole life value. And in the process of the conception and then the implementation of Living Lab, carbon has gone up the agenda, of course, rightly so. And what's quite interesting about that was I was quite worried for a while, because I thought we're going to get really pushed off course here by a kind of a whole different set of a mindset associated with the carbon data. Actually, I think that hasn't happened. And to think that the mindset is very similar, to think about whole life value in terms of cost and whole life value in terms of carbon. It's the whole life dimension that makes it that's so important. And so it's been a very reassuring for me that we're actually able to think about money and carbon in very similar ways. And actually, of course, as policies develop and measures develop, they will become even closer. So well done for solving the technology, Chris. So back to you.
Thank you very much. Yeah, so we've got a little picture there of the team. We had one opportunity or a couple of opportunities only to get together and actually work together on this stuff, which is all important with the collaboration, but online collaboration has worked for us. But this was the Accelar team working on the Living Lab, and we had the chance of taking our lunch in the shadow of the Gaia exhibition and the Millennium Point there. So, but yeah, so without further ado, the sort of areas we're covering here, as Doug was saying, are around climate resilience, biodiversity, circular economy, and carbon. And through this presentation, I'll sort of introduce some of the issues, but also take it down into those practical innovations, those things we've developed, those things that add to the applied work the industry can adopt straight away and address some of these issues. So really, this first question is, how far are we on this journey to harness specifically environmental data and in the infrastructure area? And the headline comment on that really is further than you think. There are lots of instances of this data being collected and used, and lots of links between them, how we can enhance climate resilience through nature-based solutions, as they call them, for biodiversity, how we can use circular economy and valuing materials, which also then reduces carbon in many, many ways, directly and indirectly through the transportation and so on. And we've been collecting this data for a long time, or some of this data, but we use it more for things like environmental impact assessments and the planning of these infrastructure schemes. We use it for some of that stakeholder engagement and that work where we're sort of on site and managing our consents and so on. And then operational management, there's plenty of environmental data. We've got waste transfer notes, we've got fuel bills, we've got bills of quantity, we've got inspections of culverts, we've got and lots of geospatial data, so GIS data, and a lot of remote sensing in the environmental space. But what we've not done is use that really for driving performance and seeing that as part of the overall asset value. So sort of to take an analogy, if this was a whole kind of data ecosystem around infrastructure, then I think we've got these environmental data points kind of running around a bit like insects. They're going about some really important work in that ecosystem, but they tend to be rather invisible and probably a little bit unloved compared to the more charismatic species in the jungle, which might be, the cost and the schedule and so on the projects. But what we've got also overlaying is a kind of real awakening, as you've mentioned earlier, Neil. That's awareness across society of the importance of decarbonisation and environment, and we've got policy then flowing through, and then practice in industries like the construction industry mirroring that and internalising those changes. And this is at various rates of change for across those 4 different themes. Obviously, as you've mentioned, net zero carbon, we've got the 2050 target. Perhaps more pertinent, we've got this 78% reduction in our carbon emissions in the UK. That's our target for 2035. So it's not about 2050, it's about this decade and up to about 2035 to make most of the changes we need to. And we've got carbon being picked up in the construction playbook, in the Construction Leadership Council bringing together the overarching Construct Zero initiative. We're a business champion for that, and many others are involved, and many other things around that topic. And then on biodiversity, we've got actually a very kind of grassroots reawakening of people's awareness, interest in nature through the lockdowns. People wanted to sort of get out and be in nature, and then we've got sort of the Attenborough effect and interest from that point of view. We've got global reviews on the economics of biodiversity, the hidden value of biodiversity in nature, and the DAS got to review. And then we've got the Environment Act came in last year, and that sets out a new requirement, which is not just for other sectors of the economy and development, it's also for infrastructure. So one thing within that act is around this biodiversity net gain, where each infrastructure project and development project will in time need to put back 10% more biodiversity than it impacts. So, and there's a shift there with carbon and with biodiversity. There's a shift where we're saying we need to achieve some absolutes. We can't just simply avoid the worst harm and do the best we can. We have to absolutely achieve net zero and biodiversity recovery, and that creates a different driver that the industry can then respond to, and it provides more certainty that we're really serious about this stuff as well. And back to the data, we do need lots more of it and different data. So for example, around the end of life of the assets, so that we can really determine whether modern methods of construction and those options are helping us around decarbonisation and so on. We have a bit of a paucity of data around end of life, for example. But really, as Doug said, there's a lot there that we can use better without even collecting any more data or doing anything different with it. So we've been exploring this, what can be done today, and as well as what framework should we set for the metrics and the protocols and the benchmarks and repository and so on, that infrastructure for data in the future. In terms of what are we learning? So 3 quick themes here. The benefits of consistency. Clearly there are benefits, but projects are different, client organizations and contractors and the supply chains are different, the local environment is different, so we have differences. So one size doesn't always fit all. We have many carbon calculator tools out there. We have different opportunities to reuse material. We have different habitats that we're dealing with. So we need to bridge across those 2 different, so there's a tension there between those potentially. Second one is around people. We talked about people already. I'm sure it will come up time and time again. This is a blended system here. We have not a fully digital system. We need to handle data and take the measurements ourselves, as well as remote sensing and so on. And of course, even when we have the digital system, then it's people who design the way those systems work and how they interface with each other as well. And interdisciplinary working is essential, but it is hard. And there is a risk of lost in translation and so on. And particularly in that fast-moving environment of a construction project, to be able to explain to across environmental data, digital construction, QS, surveying, engineering, all the different disciplines that can be challenging. So that's key. And then this third point really, which I'll give a couple of more specific examples around. Different scales of analysis reveal different insights, different ways of slicing and dicing. You can learn different things and then apply them and accelerate that learning of how we can make this stuff better at the same or lower cost and improve the value. So around that, we've got a couple of innovations that we've developed within the Living Labs. So I'll just give you a quick flavour for those. So first of all, around carbon benchmarking, you can do that on a kind of more top-down basis across projects and portfolios. And what we've been doing is really pushing out and exploring how far down that analysis we can go, to look down at asset level and then below asset level. So to then learn across different projects and different client partners and contractors, what's different, why is it different? We can ask ourselves different questions. So this graphic on the left is around that level 1 assets, but we found ways of bridging across, because of course there aren't the same taxonomies when you are talking within the rail industry across into the highways sector and across into different organizations and supply chains. So we've been able to bridge those different taxonomies to be able to derive this more detailed and kind of bottom-up benchmarking. Over on the right, this is one of the really big data buckets that we've already got, and that is waste. So there's an awful lot of waste data out there, but we haven't really been thinking of it as a sort of performance and performance improvement issue. It's just been a compliance issue, really. You know, amount of waste sent to landfill, the industry's made great achievements there. But beyond that, you know, there's a lot more we could do. And this graphic is something we've done to help to aggregate and visualize, you know, where are we on that inverted triangle? The waste hierarchy should be an inverted triangle. We should be, to achieve that, more retaining the value of that material, and the circular economy approach pushes us to, you know, push the value up. So we've got still some way to go on that, to move from recycling into reuse and to eliminate the last kind of disposal and go for recovery and recycling and reuse and so on. And this can be applied across a whole client and compare with another one, or a portfolio, or perhaps within a client across different regions and projects and programs and so on as well. So just to kind of move on from that into another theme that we've been looking at, which is around supply chain.
2 minutes.
Sure, yeah, no problem, Neil. Yeah, so para procurement, I've said on this slide, takes two to tango, but as you were saying earlier, you know, really this more than, and Marc was saying, more than just the tier one and the client. This is about the whole supply chain, the whole value chain coming together. So it's a bit more like trying to sort of establish the river dance rather than the just a tango with two parties. But we can basically, by looking at the supply chain as a whole, we can actually bring whole new data sets into play alongside the project data. So this first example, we've worked with IAND within the Living Lab as well. We've used their ability to automatically, where possible, harness company data around innovation capacity, net zero, carbon trajectories of the supply chain, and then bring that together and explore how does that add value and how can the industry use those. So that's one thing. A second one is looking at circular procurement. We've, with the community of practice, developed that blueprint, and that's informed by data again. So if we look here at, this is a looking at different types of materials and looking at where they are currently in terms of amount of recovery that could be moved from that blue bar into recycling and then up into that purple bar of reuse, and that varies by material type. So it tells us where we should focus our effort with the supply chain. And then really just to sort of conclude, it's about, you know, driving this performance now. We don't have any time to, the luxury of time to waste here. We need to start on the projects that are live. We need to focus on those that are already in construction or already built, and there's a lot we can do with those as well. We can pick up this in different places. And you know, one example again we've been working on is resource exchange mechanisms. So the ability to facilitate trade of surplus products across different construction sites, and the data tracking that's needed to prove those pilots there. And then the last example I'll give you is how we can actually apply carbon measurement in a forecasting way. So to look at, you know, lots of lower carbon materials now, alternatives to cement for lower carbon concrete. So we can say, actually, we've got a baseline design, we're using this material. What would it mean if we were to substitute that with some of these other products? And that allows us to kind of do that optioneering and to incorporate those changes within the fast-moving design processes as well. So really, that's where I'll end it. And we've come up with a number of further insights, about 50 or more insights and innovations. These are the kind of a number that I talked about today, and that are the most kind of ready to go. So that's the message, really. A lot of data out there and a lot of things we can do already with that to drive this carbon and environmental as part of the whole life value of these assets.
Thank you, Chris. Marc.
Thank you, Chris. Highly topical. I think we can all appreciate the sort of need to get into this space. One of the challenges we have in sort of traditional project program portfolio management is the competing factors of project delivery. So often you have safety, time, risk, schedule, competing factors. And I think carbon is now becoming a competing factor in the decision making of delivering successful projects. No doubt it's a massive part of the business case and the economic studies now in terms of what sort of carbon contributions these huge infrastructure projects will attract. What's your view in trying to actually aggregate those competing factors so that you can see and make a decision in a sort of holistic way, not just looking at carbon or environmental data in isolation? What's your view as to how to network those multiple different data sets to give a more holistic view?
Yeah, I think that's really important to do that. We can drive performance and improve things just by looking at these issues individually and using better data there. But I absolutely agree. I think we need to bring it to the table. Things like the value toolkit is a really sort of good starting point for that, because it enables us to kind of be thinking about what do we really want from our projects, and what from a strategic point of view, how do we roll that through the commercial model and everything else. But yeah, I think in practical terms, we've seen that relationship be tested, but it's very much still a work in progress around cost and carbon. There are, reduced cost, reduced carbon was something that was identified through the infrastructure carbon review about 9 years ago now. There's been an update. There's been a professional standard, publicly available standard, PAS 2080. That's now going through an upgrade as well to take that to the next level. So there's more to do there. So some of those dimensions we've already got at the table or starting to get, but I think it's about that balanced scorecard. I mean, in other areas we haven't really begun. So around climate resilience, of really thinking about, we may think we've got a good whole life value asset, but if it isn't adaptable to the future, and effectively its design life is half what we thought it was, because we're going to have to do something different as risks of storms or rainfall exacerbate through the century, then actually we're kidding ourselves. So we've got lots to do, but yeah, bringing it all to the table in that common framework. But that will take some time. But where we can get a win-win across one or two dimensions, be that cost and circular economy, cost and carbon, let's do those in the meantime, because we won't get to that perfect position of that balanced view straight away.
Sure. No, thank you. One sort of final question. In your slides, you talk about the benefits of consistency, and I think consistency is a constant challenge in sort of the program management office space, versus one size not fitting all. So in terms of carbon, and you talked about pan sector, how have you approached that to drive some sort of consistency in the analytics that we need to take?
Yeah, I think that's really challenging at times, but so important. And I think in carbon, for example, we've got now more or less consensus around sort of the whole life carbon stages and steps we need to sort of the way of viewing projects. And if we can focus on that sort of framework, but allow for a number of different tools, and kind of the way we've gone about it actually is inventing kind of analytical lenses to apply, but for them to be kind of interoperable with different tools and so on. I think that's a good way forward. So we can get consistency to the degree of what are we measuring, how are we defining certain things, what are the taxonomies, but allow for different tools and approaches to continue to emerge and not to stifle that along the way. And the IICC that Doug referred to earlier, the Intelligent Infrastructure Control Center, is another way of doing that, sort of being able to aggregate whole different types of data from different sources. But as long as we can define what those common things are, then we can then define how encourage innovation in the analytics and so on, but using a common framework for doing so.
Chris, Mark, thank you. And it's worth saying as well.
Thank you, Chris.
DFT have another project in this space, which they've just initiated, which will, I think, move us on again a bit further too. But that's really state-of-the-art thinking there, and thank you for it. And nice link to Bill, who's up next, and because Bill's sort of background is in sustainable design, but Bill's been leading working on a couple of our Living Lab projects. And Bill, over to you.
Right, hopefully you can see my screen. It's appeared, right, great. Okay, like everyone else, I'm part of a team, and I just drew the short straw on presenting today. So this is very much the work of others, but I'll try and make some sense of it for you. So I'm sort of delving into a bit more detail on something rather more specific, looking at the use of artificial intelligence to streamline cost data collection, bringing this data together we've been talking about. And we focused on cost, but you can do it with other things. Right, system to work. Right, so the problem, which has been sort of discussed a bit already, is that construction cost data is collected and organized in different ways by different sectors, organizations, and even departments within those organizations. Everyone has their own way of doing things, which has sort of grown up historically for very good reasons, but we've got a sort of panoply of different methods of collecting data. And obviously this makes it very difficult to benchmark costs of similar types of work between sectors, organizations and departments. Everyone is holding their data in different ways, and bringing it all together in a consistent way is tricky. So one solution might be to move towards some sort of common standard that will enable simpler comparison. But as you get into this, you realize that there are very good reasons why people collect information in different ways. They need information about different things and aggregate it in different ways. So that may be a holy grail, but it's a long way away, I think. The alternative might be to convert and translate this data in all these different forms to a common standard, at least so that you could report that information consistently. But the challenge of doing that is that translation between systems, it requires some in-depth understanding of both the source data and the target standard, both in terms of content and structure. So you need, if you're talking about highways works, you need someone who understands about highways work, what the language means when you're describing highways works, how that information is organized for that organization, but also then how the system that you're moving that information into in order to do this comparison, how that works. And actually that's quite a difficult thing to do. To do it manually, which would be possible, because you need this expertise, it requires expertise and it takes time. And so that's a challenge. And even when you do that, it's prone to inconsistencies because a translation requires insight, judgment, and interpretation of the two sides of the equation. And there's a lot of data to work through. So doing things manually is pretty much impossible if you're trying to deal with all this data. And that data quality is quite variable. So sifting through that data and getting it into a state where it can be manipulated is also challenging. Actually, arguably easier to do with a human than a machine, because they can make judgments. And we have the sort of fundamental multiple data formats and structures, but you also have variants and versions of those standards, because all these things are evolving all the time, and sometimes one version is not really backward compatible with the previous version. So again, more challenges. But what we have tried to do is to develop a cloud-based, semi-automated, artificial intelligence-driven system for extracting data from these various sources and then classifying them into a common standard. And the aim of doing this obviously is to make it faster to do it, which gives you quicker access to the data, making it easier and quicker to use data you've gathered. By having in effect, expert system, you can reduce some inconsistencies in the way the data is classified. And AI loves large data sets. The more data you can throw at an AI system, the better it should perform. And as a corollary of that, really, the more data you throw at it, it enables it to learn and should get more consistent as it develops. And just as an example, we've been working with National Highways to do a sort of case study. And the reasons for sort of selecting National Highways was that their work breakdown structure, the way they organize their cost information, is quite granular in fine detail. It's elemental, so it describes different types of work, so little parcels of work. And they are early adopters of the ICMS, the International Cost Management Standard, which is an internationally recognized methodology for reporting, grouping, and classifying construction project costs. So it's gaining the momentum both in this country and abroad. Not perfect, and again developing, but they have already classified a large quantity of their WBS data, work breakdown structure data. They've manually mapped it to the ICMS standard. So we had a large set of data already, which we could use for training our AI models. So for these machine learning models to work, you do need you need something for it to work on. So having this data already manually mapped to ICMS was incredibly useful. It was also useful that they have the two main departments we've been dealing with deal with slightly separate types of work, major projects and renewals. And renewals is all the maintenance work you see going on roads. Major projects are obviously, as the name suggests, larger projects, motorways, smart motorways, those sorts of things, and building new roads. The major projects division had done the mapping to ICMS. The renewals division hasn't. So they were a useful test bed to test out models that we developed for major projects and test that with new data. So just a bit of primer on these two systems very, very quickly. The WBS structure has primary categories listed here. There's sort of typical ways of thinking about a project, different elements of work, earthworks, road lighting, communications, bridge bearing structures, those sorts of things. And then the ICMS system is much less granular, which is actually helpful because you're not trying to map one to many, you're mapping many to one, less granular. Again, it's very familiar subdivision of work in the construction industry, demolition, substructure, services, those sorts of things, and preliminaries. So you might take a WBS item with its associated code. This is regulating course open graded macadam, and that's about laying tarmac, and that is mapped to an ICMS code, which is it's under structure and a subcategory of pavement. So that's the kind of mapping we're trying to do. And the way we do it, we take the original data, which could be in many forms. It could be as PDFs, as in effect text documents. It could be in spreadsheets. In this case, we were very lucky, and the information was in spreadsheets, which actually reduces the amount of sort of data manipulation you need to do in order to get it into a form which you can throw into a machine learning model. So we extract that information. So lots of spreadsheets, you pull the information out of those and get it into one place. There's some pre-processing done, which removes duplicates, tries to deal with inconsistencies in the data. So in this case, we ended up with something like 50,000 unique data items from 34 major projects. So that's the amount of sort of data we're sort of dealing with. We then apply natural language processing, which effectively converts the words in, and we're really looking at the descriptive part of the work breakdown structure, so the actual description of that tarmac. So we convert that text into numbers, which enable us to put it into a machine learning process. And what you do is you try multiple approaches to the classification of this data, different AI algorithms. I can't talk with huge authority on the detail of the algorithms, but my colleagues would be able to. You train the data on about 80% of the data set, and you then compare the results with the balance of the data set with the 20% to test for accuracy. You try a number of different methods and then select the best method, retrain it all on the whole data set, and use that for your classification model. And so you get an output of classified data, but even then you need expert assessment of that to see whether it's rubbish. And their feedback is then fed back into the model to retrain it. So that's how it works in essence. We've developed a sort of web-based application that looks something like this. This is the cost classifier. This is it'll do single items and batches. So looking at a single item, you type in a typical delightful description here, hit the button. It then returns a result repeating what you've put into it. It gives it an ICMS code and a description of the different levels of ICMS. So most important ones being structure here and pavement levels 3 and 4. So that's how it's classified that item. More powerfully, and then you can download the data if you want. More powerfully, it will deal with a file of data. So you choose the file in the normal way, submit it, and it returns the file with some extra columns on, and in the same way repeats the information you gave it and codes the item in the same way and gives you the description. Even the best experts on ICMS probably wouldn't get much value out of the code alone. So the descriptions are hugely helpful in understanding whether the thing has done something sensible. You can download that data, but you can also scroll through the data on screen and click through it. This would be the basis of a feedback system which we could develop to go with this for more general input. So you can scroll through the rest of the items. We, as I say, we developed this data using the major projects data.
2 minutes, Phill, please. Thank you.
That should be fine. So the descriptions of renewals works are very similar to highways works, as you'd expect. It's all about highways, but they're not the same. So this is a very good test of our model so whether it can actually understand the language it's being used. The focus is obviously on repair work, so it's the slightly different items come up. And the source data use a variety of bespoke versions of WBS. Different parts of the organization use a slightly different WBS system. So again, there's a very good test of taking the description as a basis for classification, and they haven't mapped it to ICMS. So this is something that would be hopefully useful to the renewals team and hasn't yet been done. So the way we've done it, you take as a whole set of descriptions. It returns an ICMS code with all the descriptions with it. And then what we've done is to review that data manually so far. You can obviously do some checks in the model, but each reviewer, in fact, marks the assessment. And red is I don't agree. Orange is not sure. And white means that seems a correct a correct classification to me. And we've done it with 3 reviewers at the moment, all blind, and then we compare the results to see how much agreement there is. And interestingly, it's always doing quite well. These are early days, but the amount of agreement between the model and an individual reviewer is not hugely dissimilar from the disagreement between individual reviewers. And we then go do a second iteration where people can see each other's assessments and modify their view as necessary. If they disagree with a code, they give another one and some notes to help understand what's going on. So, this is used to retrain the model and develop the model. So what could this be used for in the future? We could obviously apply the same techniques to other parts of the infrastructure world, and retraining the model would be easier than starting from scratch, but there's a whole, obviously if you move to a different ALB, the language will be slightly different, the classification will be different, but we can build on the work we've already done. And obviously by extrapolation, this could be applied across the building industry. And the Royal Institute of Chartered Surveyors is interested in this as a means of standardizing cost classification of projects data right across the building industry. And that's it. Thank you very much.
Phill, thank you for that glimpse into the future. It's not often you get to look into the future, but that was undoubtedly it. Thank you very much, Marc.
Thank you, Phill. Hopefully you can hear me okay. I'm sensing that, the vocals aren't so good, but if you can hear me okay, Phill?
I can, yes, thank you. And I'll stop sharing my screen, yes. Okay.
Yeah, fascinating, and it's really a space that I'm really interested in, as you can quite imagine. And certainly data structures and the relationships of data structures is something that I'm very passionate about. You mentioned AI for big data extraction and classification. What would you say are the strengths of that, and what are the limitations currently?
Yeah, I think well, shall I start with the limitations, which is obviously the wrong way to do it. But you need lots of data, but that's one of its strengths. If you've got lots of data, it loves it, and the more data you have, the more accurate it can be. I think those are really the principal things, really. Its ability to take descriptive text and analyze it in a consistent way, and learn from expert contributions to that learning, I think shows real promise, as far beyond what you would get with a sort of a lookup table type approach, where you have this quite rigid coding, which only works for one set of circumstances. The ability to use language, natural language processing effectively, to be able to adapt the model and move it to other fields, I think is very exciting.
Yeah, sure. And I think the strengths maybe in the presentation is the human processing of those volumes of data would take humans, maybe months and years, whereas the computers can do it, sort of in seconds and minutes. So certainly from a data crunching perspective.
Yeah, and painlessly too. Yeah. I think because it's always
painless. Yeah.
It's a common thread where people say, well, we've done this, and we've got loads of data waiting to be classified. It's a pretty thankless task, and actually, it's quite a difficult task, and it as I say, it needs expertise to do. It's a challenge.
It kind of leads me to my second question. So you talked about work breakdown structure and cost breakdown structure. And certainly I've been working in Highways England, National Highways in that space for a good 6 years now. And you referred to the ICMS at a level 3 of cost. Do you see there being value in going to a further detail of cost breakdown structure in this sort of analytics space?
I think it does depend on what you're using the data for. And also you can, I mean, I'm a detail man, so I tend to get obsessed with trying to get more and more detail, but actually, if you can take a step back, and I think some of the work that Doug has done and some of the others highlights that the costs of the major costs of projects, the ones that really make a difference, can be quite limited. So actually, trying to classify everything to a very fine level is maybe it can obviously be silly, and you don't get a return on it's not value for money. But I think that there is a balance. But I think the more these systems develop, and I think they also it will tend to engender more consistency in their inputs too. Because once you've got a system that's working, and you understand the sorts of information that help those systems to predict things accurately, you can go back up the chain and help people make more consistent inputs so that the models work better. I think it could generate consistency right through the process. I think the real trick, though, really is to try and take data that's sort of fundamentally necessary for a project. Which I suppose at the basic level comes down to what did somebody do on the site on a day, and did they do what they thought they were going to do? If you can take that level of data and bring it through, and then agglomerate it and classify it in different ways for the different parts of organizations and the people they're reporting to. So you're using fundamentally the same data and then easing the pain of reclassifying that for different purposes, and take it through and ideally not lose the granularity that of that rich data that when it was first generated. And that seems to be the area where data is being generated, which may have a purpose, an immediate purpose for the people directly involved. But I don't think we've realized the value of that information as it goes up the chain. And I think that's a really exciting prospect. And something like AI, in its ability to deal with vast quantities of data, makes that sort of thing possible, rather than what's happened in the past, where there's always this process of bringing data together as it goes up the chain, and you inevitably lose some of the richness of the information.
Just conscious of time, Bill and Mark, I think we need to move on. There's some excellent questions in the coming up for the end, but there's one very specific one here, Bill, for you from Andy Gordon, who knows a bit or two about these things. ICMS codes, are they easily translatable with Uniclass codes?
Into Uniclass. I think that Uniclass is obviously can deal at a much more granular level than ICMS. I'm not an expert. I mean, this is the problem. You see, you need a translator from all of these between these various codes. They should work together, but you can't go backwards. If you see it. I mean, having agglomerated stuff into ICMS, which is ideal for cost reporting, is a cost reporting standard.
Yes.
You can't feed it back up the chain.
Okay,
get more
great.
granular information.
I think that helps. Thank you, Bill, and thank you, Mark, for those questions. Right. Let's go to Phill now and give him not quite the last word, but Phill, you've been working in a similar space. Please update us on what you've been doing.
Okay, hello everybody. Can I just ask, can people see the screen? I've shared it, and so it should, I'll just be clear, that moves, right?
Yep, all good.
Okay, excellent, fantastic. Okay, so we've managed to do The technology, we've also managed to distinguish between Bill and Phill, which I was slightly concerned about following Bill. Okay, so just as all the presenters have pointed out, this is the team effort. On the screen is reference to the University of Leeds team. I would also say, however, that this work involves a variety of organisations, many on the call or on the panel today. I'd particularly like to highlight Steve Ward of Lean Construct, who has been very important in some of the process benchmarking here. Okay, so what's the purpose of my part of this event? It's actually threefold. On the one hand, it's here to talk to you about the analysis work that we've done in Living Lab to understand what's the value of all this data. What can we glean out of the data? But as you probably heard already, as you have heard, we are on a journey. Living Lab is an enabler of the future, to quote Doug. So we're not there yet. So what I'm trying to do is to bring together what you've heard today into a conclusion, and in particular, trying to refocus back on harnessing data to drive cultural change in transport, which is the theme of this event. And acknowledging that we're on a journey, but also highlighting the structures and the legacy of Living Lab that we think actually is ripe for exploitation by the sector. And if you like, this is a call to arms to say, please do, as a sector, continue engagement with the structures that we've painstakingly put together through trying to coordinate a river dance, not tango. And one of the things I'll end with is discussing with you our fantastic communities of practice and how we see them as a major legacy of this project. So if I progress to why is it that we're collecting data? It's to get some benefit from the data, and in particular, it's to identify what works from a project delivery perspective in terms of improving performance. All those 9 areas that you heard from Doug. Importantly, TIES is quite ambitious. We're trying to look at both improvements by learning within organisations, but importantly across organisations, and how actually by coming together, the cultural piece of coming together, by listening, by analysing data, by then evaluating what comes out at the end of it, we can actually highlight learning across organisations, and therefore use all this data for positive change. Now, what does that require? It requires an acceptance culturally to air one's dirty laundry in some space. That space needs to be safe. We're very much aware that infrastructure is on people's minds. It matters. It affects people's lives. Government puts an awful lot of money into infrastructure. There's an accountability issue there. But in order to do this ambition and to actually really embed learning from other organisations, we need to have that safe space. And indeed, that's been one of the key aspects of the Living Lab in the formation of the communities of practice that I'll come on to later. The other thing it requires, as well as an acceptance to air one's data in a safe space, is strategic buy-in. Because actually what you've heard today is that actually people like me and my team, the number crunchers, we could only go so far. What actually matters is that what we do is understood by the sector, and actually the limitations of what we do needs to be understood, so that the recommendations that come out of the work are proportionate, and therefore decisions can be made in a robust manner. Now, I'm trying to sell this, but I'm also trying to acknowledge that the bar is high, and I don't think we're quite there yet. So what we're trying to do here is that data standardization enables the kinds of comparisons that we would hope would identify what good looks like. But we have to recognize that in order to do that, we actually have to make sure that this analysis is robust. And it needs to be very robust in order to actually make changes to what are very complicated, very high social value, and ultimately high financial infrastructures and activities. So in my mind, the key to success comes down to data, and it comes down to engagement. So what do I mean by data? I mean the right quantity, coverage, and quality for the challenge at hand, for actually the problem at hand. And indeed, in my experience, we often get obsessed with quantity, and we often get obsessed then with quality, but actually coverage, whether you actually are measuring the right things, is often a key limit to trying to disentangle what are the elements of what are the real drivers for project performance. So what I've got here is just a note of caution. In my experience, a lot of benchmarking exercises set off like they're in the Olympics at the beginning. And what actually happens is that benchmarking exercises exist for 1 year, for 2 years, and then they stop. And all the learning that comes from those benchmarking exercises is lost, and we just start again. Now, why does that tend to happen? It tends to happen because we think that if we do something, if we put some investment in, then we will instantly get the right answer. It certainly is not that certainly is not the case. We need to be iterative. We need to recognize that in order to get the right data, we first need to define the problem. We can then collect data. Yes, that data will not be perfect, and we need to be able to show the value of that data and how analysis starts to point us towards where the gains are likely to be. But then we will need to keep going, and we will need to keep going. So what we need to do here is raise the bar over time, not simply think that we've solved the problem straight away. And I think that's something that has come through all the presentations so far. So in terms of the insights that we've found during our activities in Living Lab in terms of analysing the data is firstly to just acknowledge that there are lots of ways to analyse data. I've got 4 examples here. Within these 4, there are various subdivisions, but we can think of something that ranges from qualitative mapping of processes and trying to understand pinch points in those processes and barriers, through to statistical approaches, be that kinds of regression analysis or machine learning even, all the way down to more granular, more, if you like, on the ground type process benchmarking. And one example being lean analysis. And the natural question is, so why do you need all these methods, and which one do you choose? Well, each method answers subtly different questions. So therefore, one is more applicable in different circumstances. But often what we find in this area is once you've got data, one has to look at it from various different perspectives. Perhaps the example here is the idea of trying to think about what can the kind of number crunching methods tell you. They usually tell you something that says this project looked good. And the natural question to ask is why? To do that, one often thinks about actually going to do a deep dive, process benchmarking type analysis of those identified projects. So this idea of triangulation of method is really important to provide robust insight into the drivers of project performance, and ultimately to drive robust decision making. And by decision making, ultimately what we mean is changes in delivery and planning of projects. So two very brief examples of the kinds of insights that we've provided as part of our work in Living Lab. The picture on the left is all about what we can get out of some of the statistical analyses. Here, this is all about trying to understand whether there exists optimal size of projects. So using various data, we've built models to try and explain why there is cost variation across projects. And as you can see here, the evidence that we find is there's a sweet spot in terms of the size of projects. There appears to be, in a lot of the examples we look at, an indication that some projects could be better delivered as larger projects in terms of reducing unit costs, whilst others, and perhaps that comes from things like recognizing that projects take substantial times to set up in terms of to set up sites, so therefore it makes sense to try and do it on a relatively large scale. But ultimately, we find that actually projects can be too large from a cost perspective, and that potentially is around whether things like the supply chain can actually deliver on that scale, or whether actually trying to deliver on such a large scale produces skills challenges in terms of getting the right people to site, and ultimately starts to create rigidities. So on the one hand, we've got okay, thank you. Cheers. Okay, and then another example is the kind of qualitative mapping that we've been trying to do to understand how we can unblock some of the challenges in actually incentivizing the supply chain to embed carbon saving measures within the development and construction of projects. Okay, so my last slide. I want to talk about legacy, and the legacy of Ties Living Lab, in my mind, is the communities of practice. Doug has already outlined to you the principle of the communities of practice. It's about bringing together representatives, subject matter experts from the infrastructure client organisations together, so that we can jointly set the agenda for what is it that we want to look at into the future. So this is about sharing experience, identifying issues. It's about harmonizing data collection. So we talked about protocols, for example, and making sure that we've got a sensible ask of the supply chain. It is about analysis, but it's about assimilating what that analysis means, and actually then saying, well, actually, this analysis needs to be developed in this way for it to be really influential and helpful in our organisations. And importantly, it's about sharing practices of implementation. All that is a reinforcing circle, and all this takes time. And perhaps the key message out of my presentation is to say, yes, we've done a lot in Living Lab in terms of collecting data on a comparable basis, setting out how data can be collected better and in a more consistent manner, and also analysing data. But we are on a road here. Living Lab is an enabler for the future. We are trying to do a river dance, not a tango. And so, to me, I would urge the sector to really consider that the Ties Living Lab has laid the foundations for this activity continuing in the future. And if you hear about the communities of practice, if you get approached by the communities of practice, please do engage, because this could be and should be a sector leading and a sector enabling excellent good news story. Thank you.
Phill, thank you. Thank you, Phill. Marc.
Yeah, I'm just going to keep it really brief because I'm sure there are some other questions out there. One last big question for you, Phill. So we have a lot of data. Why is it such a challenge in getting the strategic insights out of benchmarking, and how can this be improved?
Yeah, thank you for that one. I tried to hint at it slightly early in my presentation. I think there are two key issues. One's a sort of, if you like, a technical issue. Loads of data, but it's on the wrong things in an inconsistent manner. And I think we've made massive progress in highlighting instances of that and actually recognizing that with coordination across infrastructure managers, one can get to a stage where we're asking those consistent questions and getting consistent data from the supply chain. So that's the first thing, that actually we have loads of data, but none of it really talks to each other, right? Or there's often key limits. The second one, I think, is talks more to the cultural piece, and is very much around, this is not something that just data analysts need to do. Indeed, if you ask data analysts to do something, you'll probably get something that's very unuseful out the end. It needs buy-in, it needs engagement with not just the client, but the clients, and that's where we need to recognize that the communities of practice are really important. They are bringing together all these interested parties, all the parties that can benefit from this data analysis. And perhaps my plea from a strategic buy-in perspective is, these people need time. I don't think it's just about money. It's not just about people putting pounds and pence in to this kind of effort. It's also about making sure those experts have the time to not just attend meetings, but to be able to actually reflect on what is being discussed and push forward initiatives within their organisation. So to me, the whole cultural strategic buy-in piece is really important here, if this is to be a success into the future.
Thank you, Phill.
Thank you, Phill. Thank you, Marc. Just a couple of minutes to go. We've got some really cracking questions that I'm not sure we're going to be able to do justice to, but we'll have a go. To all the panel, how do we ensure the cost of data capture is driving the performance value required? Related, is there a kind of benchmark for what percentage that should be? So how do we make sure we get the return on investment from this time, and what is the right investment? Who wants to have a go?
Shall I have a go at that one, Neil, first there? Yeah, I mean, I think making sure we get value out of it, I think, is making sure that we're collecting the right data and we're using that data for the right purposes as well. And I think we continually need to monitor that. So we can't set things up today that will be in place for the next 15 years. We need to be looking and seeing how things change, because even in what we set up 2 years ago in the Living Lab, things are looking quite different. On that second question around, is there a rule of thumb for what percentage we should be spending on data? I think we need to be very careful, and I think I'd be very wary about doing that. And the reason for that is this has got to become business as usual. It's got to be helping people get it into their day jobs and actually help them with because you run a risk, let's say X percentage, I won't put a number on it, but let's say you say we will spend X percentage on data collection. It just becomes another silo, and that's their job over there, to collect the data and analyze the data. And actually, it doesn't integrate into what we're doing as a business and as an organization. I think that's the bit we need to end up on. And I would echo Phil's point at the end there around actually allowing people the opportunity to be able to embed that into what it is they're doing. So great.
Thanks, Doug. I mean, this is not an optional activity. This is part of how we're going to work. The only 22% of businesses have a meaningful data capability at the moment, but that's doubling every year. There are 9 vacancies for every data analyst candidate, which just tells you that we're not alone in thinking about this. And a couple of people have talked about the human factors as well, not a topic for today, but for another time. Huge thank you to our panel. Ladies and gentlemen, you will rarely have had such a broad but insightful update on where we are. And thank you for your comments today and for all the hard work you're putting into the Living Lab. It's much appreciated and really moving us forward. So thank you again to you all. Thank you to the audience for coming on the journey. And you have been professionally developed, so pat yourselves on the back. Now, there's a couple of just announcements to the audience, please, if I may. The first is please fill in the survey. It really helps us. The second is some of you doughty souls will have been at all 4. If you've done that, you will be entered into a prize draw to win an iPad. So sit tight. We know who you are. The third is we promised some places at our May and July conferences to people who attended these sessions, and we've kept some places back. These are in-person conferences in London, and we have some spaces for next week, Wednesday 25th, and for July 13th. And so please contact my team if you would like to go to either of these events. They're both full day events, invitation only, and we've kept some places back for our online audience. So thank you again to everybody. It's time to close, and I hope you have a good rest of the day and weekend. Thank you.
Thank you all. Thank you, Neil.
Thanks, Neil.